All right, so in this lesson, we will describe relationships in terms of causality, correlation, and correlation coefficient. Now let's just dive right in. So this first statement says, the more time you spend running on a treadmill, the more calories you burn. So the more time, the more calories burned. I guess I should maybe more calories burned, right? This is a positive relationship. As one increases, as x increases, y increases. The question is, does running on a treadmill cause calories to be burned? It's like, yes. So it's most likely, or may as well be causal. It causes this one, x, with this first one, this x causes this y increase. This x increase causes the y increase. This next one says, the longer amount of time you spend in the bath, the more wrinkly your skin becomes. So that's an increase in time, right? The more wrinkly your skin gets, so that's an increase in y. So that's a positive relationship. And yeah, I mean, like, we're pretty sure most sitting there, like, it doesn't happen when I'm not in there, right? So as the time you use your Chromebook increases, the amount of battery life decreases. So as the time, which is x, increases, the amount of battery life decreases. So as x increases, y decreases. This is a negative relationship. So, and yeah, like, using your Chromebook causes the battery to go down. So that's causal. Like, the time going up causes the battery to go down. The amount of time you spend in the bath causes or may as well, cause the skin to, get wrinkly. So, as the amount of ice cream sold increases, so ice cream sold increases, the number of swimsuits also increases. Okay, so as x increases, y increases. This is positive correlation. Positive correlation. Remember, these are a correlation. But does selling ice cream cause swimsuits to also be sold? No. They're related, but it's not causal. Selling ice cream does not cause selling swimsuits, right? So the more you wear your lucky socks, the number of times you lose decreases. So the more times you wear your lucky socks, as that increases, the number of times you lose, maybe that game or whatever, decreases. So this is a negative correlation. But your lucky socks, I know they're lucky, but they really don't have an effect on whether you win or lose. So this is not causal. You could even put related, but not causal. Let's do that. There's something to it. Maybe it's because you feel more confident. I don't know. So they're related, but it's not causal. As more fighter fires show up, the damage to houses increases. So as firefighters show up, more of them, the damage to the house increases. So that's a positive correlation. But firefighters showing up does not cause damage. Firefighters showing up does not cause damage. It just means there's a bigger fire. So they're related, but the firefighters don't cause the fire to increase. All right, cool. Next page. All right, so let's zoom to something that makes more sense. Okay, so we're going to talk about correlations. Remember, correlation, let me try a different color, I guess. Correlation is a relationship between two variables. This is a relationship between two variables, or two things that can change, right? Like as x increases, y increases, I can make that a little bit better. Variables. So, we use a number to describe if something's very strong. For instance, if this x and this y, or I guess I'll put it over here, if this x and this y are completely unrelated, look, they're not related, nothing, it's random, it looks like. This is called no correlation. No correlation means you have a correlation coefficient. R is a relationship, basically, number. A correlation let me do that. Correlation coefficient. So the correlation coefficient. So like that one is 0, this one's 0.4, this one's 0.8, this is 1, right? So this tells you how strong the relationship is. So how strong the relationship is. Why can't I do this? How strong the relationship is. So for instance, if there's no, this x and y are not related at all, then the correlation coefficient will be 0. If they are perfectly related, like they're perfectly in line, like if you know that this goes up a little bit, this goes up, this goes up. If they're so related, like it's just very obvious, like in this straight line, you get a correlation coefficient, an R of 1. But usually you don't get a 0. Usually you don't get a 1. Usually you get something in between. So for instance, if it's a weak positive relationship, right, a weak positive correlation, you can get like a 0.4. Like here, for instance, if we try to line, the line doesn't work, right? And no matter what way you put it. So maybe I should do this. That's why there's no correlation. If you try here, well, I guess I can do a little better. Then you can tell, like, it's sort of there, like 0.4, right? And then if you look at this one, like, look how close they are to being related, that knowing one will help you know the other. Like, if you know x is this, you almost know what y is. If x is this, you almost know what y is, right? But this one is they're perfectly related. So, like, if you know what x is, you know what y is. If you know what x is, you know what y is. You can keep, like, you can see that it continues in a constant rate, right? So, 0 relationship. 0.4, you know, there's a little bit there. 0.8, oh, it's really something. Like there's a relationship between this x and y. And then a perfect would be like, bam, straight line in a row. Now let's talk about negative relationships. Negative correlations. Negative correlations. Negative correlations. Negative correlations. So once again, we have an x and a y. Once again, there's no correlation. Like if I tried, like bam, nothing. Like it's not a good predictor. If I try here, drawing downward is going to be a little more difficult for me per usual. Oh, there it is. You can see that they're somewhat related, you know. So it's a negative 0.3 maybe. I just sort of guesstimated these, right? And this is a strong negative correlation. You say I was like strongly they are like related. You can use one to almost guess the other one. And so negative 0.75. See, you're trying to get to 1. 0, no relationship. 1, perfect, like positive relationship. 0, not related. This should be negative 1. Negative 1. That means they're perfectly related, but as one increases, the other decreases. So this negative here, this negative here, means it decreases. Well, I guess I could put it up here. This means a decrease. So as x increases, y decreases. Probably put decreases a little better. So that means as x increases, y decreases. So as x goes up, well, that's no correlation. As x goes up, y generally goes down. As x goes up, y generally decreases. As x increases, y definitely decreases. You know, perfect path. All right, let's look at the next one. Next page. So we have to be able to do this, right? Like to calculate a correlation coefficient. Let's do that. Okay, let's go ahead and do that. But we need the calculator. So I got this bad boy right here. It's going to make everything smaller, so I'm probably going to have to zoom in. So let's see if that'll work. Okay. So I got to put these in. So the first thing I want you to do is I want you to go down here where it says spreadsheet and click that. And then I'm going to put, well, this is not going to be fun. So let me move this a little bit. There we go. So this is counting by tens, right?